So today I will be finishing the objective that states I will be able to predict future motion of an object which is experiencing normal and frictional forces. And so for my problem, I have a horseshoe object that is traveling on a rubber surface, and the initial velocity is in the x direction, the positive x direction of 100 meters per second. And then the force that is pulling this horseshoe actually slows down, and using this following diagram, we are going to figure out where the object is after 2 seconds, and we're going to assume that the object can actually go backwards, and the mass is going to be 10 kilograms. And so the first thing we're going to do is find the normal force, and in order to find the normal force we have to find the mu value, and the mu value is unique to the surface, so this time I'm using rubber and horseshoe, and the mu value here is 0.68, and it's unitless number. And what I'm going to do then is multiply it by the force that was shown on the previous diagram. Next, I'm going to update the force, the net force. And so what I do there is, again, I go back to the diagram and I calculate all the forces, and I find that the y forces cancel out and the x forces actually give us negative 30.4 newtons, which is telling us that the force is going in the negative x direction, excuse me. And then the next thing we're going to do is we're going to find our change in momentum, and we're just going to use the velocity times mass for that, and what we get is a 1000 kilograms meters per second. Okay, and then finally we can use the iterative method, and by going through that with a delta t of 2, I'm able to find that the object will actually go backwards in space to get us a negative 1000 meters per, or just meters, because it's position. Thank you.